All right. So this is next part for the computer. I said pewter, I guess is what I'm calling it. So this is the ALU. Um, Basically, it has a 3 by 8 decoder. So these first 3 bits, right, is what determines the operations to be done on A and B. You know, byte A and byte B. And this is the output right here. The output byte from whatever operation is being performed. And this is whether or not the output byte is 0, or if A is larger than B, if byte A is larger than byte B, or if byte A and B are equal. And these 3 things will always be outputting no matter what operation you're doing. So as you can see, it shows that A is larger. And if it's 0, the output right here, see that the output's just consistently just 0. If I was doing different operation, this might change. And then, if I chose some random number, it'll show that, A is larger, and it shows whether or not they're equal depending on the operation. So if I could pick an operation here. So I can see that 1 is connected to the comparator. A weird name. So it'll just compare whether, you know, whether 1 is greater than the other. Well, I guess the comparator really is doing, it's just really an XOR. I'm sorry, because the comparator by default is always outputting, is using an XOR operation for each one of these bit compares. So it's just outputting that XOR, and then the equal and then A larger is just always being output. So this is actually an XOR. I select the first bit. So, if I did these 2 bits, these cancel out. If I did this, it's only selecting 1 if they're one's on and one's off, then it's going to, be a 1. You can see that's working right there. Or if I wanted to do, for 2, if I want to do an OR, so I could do bit 2. So if either one of them are selected, then, you see the output bit kind of works, and it shows, this is still working. And then for 3, what do we got? An AND. So only if they're both equal to 1 will it output that byte. As you can see right here, the output byte. And then 4 is a NOT. Whoops. This is 4. So if A is on, but then B is not on, then it's false. So if they're both true, then it's going to turn out false. That's kind of how NOT works. Opposite of 1. Actually, I'm thinking about this. A is 0, and then B is 1. Would the output still be 1 when it comes to a NOT? They think so. I don't know. Is this a function? Yeah, I think. Uh, let's go with binary 0, 1. Yeah. So I guess if the first bit is 1, and the second bit is oh, I see. It's just gonna whatever's 1 will now be 0, and whatever's 0, it's only 0 will now be 1. It's only messing with bit A. I'm dumb. This is 1, so it'll be 0. This is 0, it'll be 1. This is 1, it'll be 0. I don't know why it was what I was thinking. And then we have a shift left for, what is this, 3? Or 5, I mean, 4, 5. So if I, take these 2 bits and they're shifted to the left, see they go down 1, or I could shift to the right. If I go to 6, see it's these 2 bits are shifted to the right, or I can do, the addition that we've seen before. So if I, select all the bits, form addition, you know, it's 3 plus 1 is 4, then output's 4. Yep. So that's the basic ALU. I don't think I showed the comparator. No, I showed the addition. So this isn't too much. It's kind of similar to the, well, it's not similar to the addition, but we're taking, bit A and bit B, and we're doing some logic here. We're seeing if, they're unequal, then we just continue on to C, which C is just, the XOR. It's a regular XOR for each bit. And if, they're equal, we can determine that if they're not, XOR, if they're not XOR and the previous bit is equal, then we continue to say that it's equal through each bit. And if A is not on and they're not like an XOR, then that means, A must be off. So if A is, I'm sorry, that A must be on and A must be greater than B. So that just, this is going to output that A is greater than B, and it's going to continue that, through the chain all the way down, the equal and then the A larger all the way down until the end. That's the comparator, or just a chain of ors, and chain of ands, not, whoops, not just a bunch of knots. Shift left, you can just see we're taking the input and then moving 0 to 1, 1 to 2, pretty simple. Shift right, pretty much the same thing, and the last bit gets wrapped around. And then the adder, we already seen. Yeah, and then this is the checks if the output is 0. I don't know if I showed the decoder, but it's not too hard to understand. It's a little bit of a mess. So this is, 3 ands or 2 ands, chained together. And then we just determine if the bits are on or off, to determine what, number we're on. And then it's gonna get output. So yeah, that's the ALU.